Today we're going to talk about how to solve a system of equations that has three equations with three unknowns. So to start these types of questions, I want to go through an example where we have three equations here, and each equation has three unknowns. And we're going to use a technique, or a couple techniques together, that will allow us to solve for the values of x, y, and z that satisfy this system of equations. So we're going to call each of these, let's denote each of these equations by the number 1, 2, and 3. So the first one is equation 1 up here, middle one's equation 2, and then the last one's equation 3. Similar to what I did before, I do want to kind of write out steps for this process that will hopefully help you guys if kind of following steps is helpful when we approach these types of math questions. So the first thing we're going to do here is, once we have our system of equations, we're going to take our functions and we're going to write all equations in standard form. Okay, and what I mean by that is ax plus by plus cz equals some number, let's call it d. Could be the number 0. It's going to be different depending on each question. And so notice here that each of these is written in standard form, so that step is already done for us. And most of the questions you're going to see today are already in standard form, just to keep it simple. Step number 2, clear any decimals or fractions. So like, for example, and this is going to make life a lot easier, if I had a 1/2 over here somewhere, multiply the whole thing by 2. That way you get rid of the 1/2 and you don't have to deal with fractions. If you can avoid using fractions, do it. All right, the steps number 3, 4, and 5 are the most important here. So we already have these written in standard form, and there aren't any fractions. So now we're going to get into how to approach these types of questions to find the solution. So we're going to choose a variable to eliminate. It actually doesn't matter which variable you pick. Some variables might be a little bit easier than others, though. So for this one, I'm going to pick the variable y to eliminate. Okay. Okay, so we're going to choose a pair of the three equations. This is still part of step 3. We're going to choose a pair of these three equations and eliminate the variable. Okay, so for this one, we're going to eliminate the variable y. So the first thing I'm going to do is, let's take the first pair here. Let's take this pair, and I'm going to eliminate y by rewriting these equations here, except for the second equation, I'm going to multiply the entire equation by the number 2. So I'm going to multiply the second equation by the number 2. Okay, and now let's rewrite it again. So we have 4x minus 2y minus 3z equals 5. And we're going to distribute the 2 to each of these terms. Negative 16. Sorry, not 2. I'm going to multiply by negative 2. Negative 2. So this becomes positive 16. Positive 16, sorry about that. Plus 2y minus 4. Looks like I wrote this wrong. Again, sorry about that. Plus z. So this becomes minus 2z equals positive 10. So if we multiply the second equation by negative 2, we end up with this form here where we can now eliminate the y terms by adding these together. So 4x plus 16x, well, this is going to be 20x. And notice here, the y terms go away, minus 5z equals 15. Okay, so that's the first part of step 3. Now the second part of step 3 is we're going to use two other equations. Let's use these ones right here. And let's eliminate y for these ones. This one's going to be a little bit easier because notice that if I don't need to multiply each equation by any number. All I have to do here is add these together. So you want to pick a variable, and the key here is just, the key to being able to do this well is just practice. You want to pick a variable. You'll get a kind of a feel for it. Pick a variable that allows you to eliminate that variable easily. Okay, and so let's add these together. I'm just going to move this down a little bit. Let's add these together and notice that we can eliminate the variable y without that much arithmetic because we have a negative y in the first equation and then a positive y in the second equation. So we end up with negative 6x. Y's go away again. Plus 3z equals 0. Okay, that's step number 3. And 4 together. So we're going to use a different pair and eliminate the same variable as step 3. So here's step 3 over here. This is step 4. Okay, so step 5. Looks like I have to move this down a little bit more. Step 5 is we're going to use these. See how we have two equations now? We have one equation here. We have this equation here. And we have this equation here. So step 5 is, well, that's a system of equations. So we're going to solve the system of equation. From steps 3 and 4. All right, so here's our system of equation. So let's get rid of the z term by multiplying the first. Let's use elimination here. First equation by the number 3, and the second equation by 5. And so if we rewrite this, we get 60x minus 15z equals 45. Negative 30x plus 15z equals 0. Now let's add these together. So 30x, the z's will go away, equals 45. And so x is equal to 45 over 30. If we divide both the numerator and the denominator by 15, we get 3 over 2. So x is 3 over 2. Now to finish up step 5, we need to solve this system of equation. And to do that, we're just going to use one of these equations here. We'll call this equation 4, and this is equation 5. And we can pick either one, and we're going to plug in x in order to solve z. So let's just pick the equation number 5 because it looks to be a little bit easier to work with. So negative 6x plus 3z equals 0, and I'm going to plug in x equals 3 over 2 into this equation here. So negative 6, 3 over 2 plus 3 times z equals 0. So negative 18 over 2 plus 3z equals 0. Well, we get 9 plus 3z equals 0. Negative 9. 3z equals 9. So z equals 3. Okay, we're almost done. These can be pretty annoying because there's just a lot of steps. So here is, I'll save it for the end. So we have x and z, and so now the last and final step here is we're going to use, so step 6, is we're going to use one of the original equations to solve for remaining variable. All right, so we're going to use one of the originals to solve for the remaining variable. I think let's use the last one. You want to pick one that doesn't have that many negatives. That's usually how I approach these. So I'm going to pick the last one. And so let's rewrite equation number 3 over here. So 2x plus y plus 2z equals 5. We're going to plug in the x value that we calculated, which is 3 over 2, plus y. We still don't know what that is. We're solving for that. Plus 2 times 3 equals 5. Okay. So we end up with 3 plus y plus 6 equals 5. Well, 9 plus y equals 5. And so if we subtract 9 on both sides, y is equal to negative 4. So the x, comma y, comma z values that satisfy this equation are 3 over 2, comma negative 4, comma 3. And that is the answer for this one. Okay, so that's a lot of work. Hopefully that was clear. There's a lot going on, so it's easy to kind of mix up steps. But here are the 6 main steps to approach these questions. The main problem I've seen with students dealing with these types of questions is just making simple arithmetic mistakes, and that can ruin everything, especially if you do it at the beginning. So really check your work and make sure you don't make those mistakes. Otherwise, it's going to ruin your answer. Okay, these take a while, so I just want to go through one more, and then most of the time in class today is going to be practicing these types of questions. All right, so here I'll go through this one to wrap up this video. So we want to solve the following system of equation. Start by thinking about what variable is a good variable to cancel out. Ideally, if you see a plus or a minus, that might be one you want to pick because that means you'll be doing less work. I think I'm going to go with the variable z to eliminate here first. Y is also a good one to pick. It really doesn't matter. If you do it correctly, you will end up with the right answer. So there's numerous different ways you can do these questions. So let's eliminate the variable z. Let's start there. And to do that, I'm going to take the first equation. Let's rewrite it. And let's rewrite the second equation. Okay, notice for this one, all I need to do here is add these together. Because if I add these together, I end up with 2x minus y, and the z's will go away. So this is equal to 5. The z's are already gone. Now, let's, you could do the second and third equation, but I think it's actually going to be easier if we add the first equation with the third equation. Okay, let me show you why. Because if we want to cancel out the z's here, rather than multiplying everything by -2, all we have to do is multiply everything for the first equation by a +2. And so it's just going to make the arithmetic easier to deal with. So if we multiply the first equation by +2, each term in the equation gets multiplied by 2, and so there's an 8 over here on the right. And the second equation, well, this is really the third equation, that's going to stay the same. And now we're going to add these together. Okay, 2x plus 2x, that's 4x. 2y minus y, that's plus y. And these z's will go away again. Equals 8 minus 1, 7. Okay, so now we have a 2 by 2 system of equations. Let's add these together. And without doing anything, this is nice because if we add these together, automatically the y terms go away. And so we end up with 6x is equal to 12. And now x is equal to 2. Okay, so now this is really equation 4, or yeah, equation 4, and this will be equation 5. And then what we're going to do is we're going to pick this x value, and we're going to plug it into either equation 4 or 5. It doesn't matter, you're going to get the same answer, and then solve for y. So I think equation 4 might be easier to plug into. So let's just bring this equation down here. Let's bring this down here, and let's plug in x equals 2 into this equation. So if we plug in x equals 2, 4 minus y equals 5. Let's add y on both sides. And then subtract 5. So the y value is -1. So we have an x, we have a y. All we need now is the z. And that is going to come from going back to the original three equations at the beginning. Let's pick the first one, because this one doesn't have any negatives. This one looks like it's easy to work with. So equation number 1 says that x plus y plus z is equal to the number 4. Well, we know x, we know y, we just need to plug those values in order to solve for z. So x is equal to 2 plus y is equal to -1. I'll just write -1 here. Plus z is equal to 4. So now 1 plus z is equal to 4. The z value is equal to 4 minus 1, which is 3. And so x comma y comma z is equal to 2 comma -1 comma 3. And that is going to be the answer for this practice question. So in terms of visualizing what the solution is going to look like here, it's a little tricky to do, but this is actually a plane, and the solution is going to be the intersection of these 3 planes. So there's 3 planes, and they intersect at the coordinate point 2 comma negative 1 comma 3. Okay, that's how you can kind of visualize what the solution is. Okay, so the remaining time in class it's mostly just going to be practice. So I want you guys to start with problem set number 1. Solve these 2 systems of equations here. Check your work with the answer key below. If you're stuck or if you have any questions, just come into my Zoom room and let me know.